algebra.
Good morning. Today we are going to start on the next section in this chapter, and that has to do with inverse trigonometric functions. So let's get into that. This is inverse trigonometric functions. Okay, so sometimes you'll hear me refer to them as arc trig functions. That is another way that we refer to them. So in your book, you will see that they are called arc sine. Sometimes we write them as sine inverse, which looks like sine to the power of -1 of x, but they are all the same thing, just written in a different way. Now we start with some definitions. We've dealt a lot already with the basic trigonometric functions, your sine, cos, and tan, and their reciprocals as well. So now we're interested in the inverse of these functions. So the first one, we have y is equal to arc sine of x. So I think I will write it as sine inverse of x. I believe that's even how it appears on your calculator. So if you have a function y is equal to sine inverse of x, this means that x is equal to sine of y. So you have this function, or this equation, x is equal to sine y, and how we make y the subject of the formula is by taking arc sine or sine inverse on both sides. Then arc sine and sine cancel each other out. That's why you see I have only x here, and then on the other side there is a sine. So these are inverse function, like square root and square. They cancel each other out. So I'm not multiplying by sine on both sides, just like when I say I'm taking the square root on both sides, I'm not multiplying by a square root. Or when I take logarithms on both sides, I'm not multiplying by logarithm. I am applying a function which will cancel another one out. So that is the first definition, that if y is equal to sine inverse of x, then x is equal to sine of y. Also, if y is equal to cos inverse, this means that x is equal to cos of y. If y is equal to tan inverse of x, this means that x is equal to tan of y. And you need to keep in mind what all these functions mean. What does sine of y mean? Opposite over the adjacent. What does cos mean? Adjacent, opposite over hypotenuse. I hope that's what I said. And then cos, adjacent over hypotenuse. Tan is opposite over adjacent. So we'll use those quite a bit. Now here we should take note that for the first one, y is in the interval -90 to 90. Okay, for the second one, y is in the interval from 0 to 180. And here, y is in the interval of minus 90, open brackets. Okay, so these are our angles in degrees. So we know how the graphs of cos, sine, and tan look. And last semester, when we're sketching graphs, you learned how to sketch the inverse of a graph. You have to reflect it along the line y is equal to x. So the same thing applies here. You can draw the graph of y is equal to sine x. You draw the line y is equal to x, and then you reflect your graph. Now what you will end up with, so the graphs, you have your x-axis, you have your y-axis, looks something like that. This is 1 here, and this is minus 1, and this is the graph y is equal to sine inverse of x. Then cos inverse of x, looks something like that. This is minus 1, and that is 1. This is the graph of y is equal to cos inverse of x. So again, remember, cos inverse and arc cos mean the same thing. It's just a different way of writing it. So in the book, they use arc a lot. So we're saying the same thing. Then the other one for tan inverse, this one has horizontal asymptotes. This one is at minus pi over 2, and that is at pi over 2. So this is your graph. You should label these as well. This is pi over 2. This is negative pi over 2, as we know that sine of 90 or pi over 2 is 1. So sine inverse of 1 should give us pi over 2. And here we have pi, because cos of pi is minus 1. So cos inverse of minus 1 is pi. And same thing, cos of 0 is 1. So cos inverse of 0 is 1. Okay, so those are our graphs. That is what they look like. Mostly we will be dealing with the functions themselves, not necessarily the graphs, but it's always good to know what the graphs look like. Okay, then we get into the derivatives of these functions. The derivatives of our arc-trig functions. We'll start with the function y is equal to sine inverse of x. So remember, if y is equal to sine inverse of x, we want to find dy dx, or y prime. Now we don't know how to work out or what the derivative of sine inverse of x is. So maybe what would help us is if we rewrite this function where x is the subject of the formula. And we did that already. We said that this is the same as x is equal to sine of y. Now when I look at this function, I know how to differentiate it because I have a sine. The derivative of sine is cos, and this will be an implicit differentiation, and then I'll have a y prime and then just make y prime the subject of the formula. So this is easier to differentiate than this one because I'm not sure what the derivative of that is. So if we have x is equal to sine y, we differentiate it. On the left, the derivative is 1, and then on the right, the derivative of sine, we say it's cos y, and then we multiply by the derivative of y. So remember, we want to work out y prime. So y prime is equal to 1 over cos of y. So that is the derivative of sine inverse of x. But if you look at our function, it was in terms of x, and we always want to leave things in terms of x. So what we do is, can we not find a way to write this cos of y in terms of x? So what we do is we draw a triangle, a right angle triangle like this one. Okay, and then we look at this relationship. X is equal to sine y, or sine y is equal to x. Now we know that sine is opposite over hypotenuse. So I'm going to put my angle y in the triangle. So you can put it there. And we are saying that sine of this angle is opposite over the hypotenuse. So my opposite divided by my hypotenuse should be equal to x. So I just need a fraction. So here I have x. I can write x as a fraction as x over 1. So that would mean my opposite is x. My hypotenuse is 1. And because this is a right angle triangle, I can work out this side, and I get the square root of 1 minus x squared. Okay, then using this triangle that I formed from this relationship, I ask myself, what is cos y equal to? Remember, cos means adjacent over the hypotenuse. So I go to my triangle. Cos is adjacent divided by the hypotenuse. So it's the square root of 1 minus x squared divided by 1, which is just the square root of 1 minus x squared. So y prime is equal to 1 divided by the square root of 1 minus x squared. So the function that we started with was y is equal to sine inverse of x. When we differentiate that, y prime of this function here is 1. Let me just write that so it looks clear. The square root of 1 minus x squared. Okay, so that is the derivative. Okay, so whenever you're asked to differentiate sine inverse of x, the derivative is 1 over the square root of 1 minus x squared. Then we can do the same thing with cos inverse of x. We follow the same method. So we have y is equal to cos inverse of x. Remember, this just means that x is equal to cos of y. And we know how to differentiate cos. So we have x is equal to cos of y. Differentiating both sides, we have 1 is equal to negative sine y multiplied by y prime. And then making y prime the subject, we have y prime. This is equal to minus 1 over sine of y. Then, like we did in the previous example, what we do is we draw a triangle to represent x is equal to cos y. So this is a right angle triangle. You put y over here. Now remember, cos means adjacent over the hypotenuse. So adjacent divided by the hypotenuse here gives me x. So this is adjacent over hypotenuse. That is how I'll get x. And then using Pythagoras theorem, I work out what this is equal to. So this is equal to the square root of 1 minus x squared. And then I want to work out sine x, sine y rather, in terms of x. Sine y, remember, is opposite over the hypotenuse. So that will be the square root of 1 minus x squared divided by 1, which is just square root of 1 minus x squared. So y prime is equal to negative 1 minus x squared. Okay, so this is our derivative when we have cos inverse of x. And then the third one is when y is equal to tan inverse of x. We have y is equal to tan inverse of x. So this means that x is equal to tan of y, and then we can differentiate this in the same way. Here we have 1. This is equal to the derivative of tan is sec squared of y, and we multiply by y prime. So y prime, this is equal to 1 over sec squared of y. Okay, and we know that sec squared of y, 1 over sec squared rather, is equal to cos squared. So this is just cos squared of y. Then we have our triangle again. And we have x is equal to tan of y. So the opposite over the adjacent is our tan, and then we use Pythagoras theorem to work out the hypotenuse. So this is the square root of 1 plus x squared. Okay, so from our triangle over here, cos of y is the adjacent over the hypotenuse, but we want cos squared. Remember, cos squared just means multiply cos, or find cos y and then you square it. Okay, so we have cos of y. This is 1 over the square root of 1 plus x squared. So if you want cos squared of y, we square this, and then we will get 1 over 1 plus x squared. So our y prime is in fact equal to 1 over 1 plus x squared, and that is the derivative of tan inverse of x. Okay, then from here you can also work out the derivatives of sec inverse, cosec inverse, and cot inverse. You do them in the same way. It's not too challenging, but most of the time what we will be differentiating will not just be tan inverse, it'll be not just tan inverse of x, it'll be tan inverse of a function of x. So when we differentiate those, what happens is we use the chain rule to get our derivatives. And what the derivatives look like, and write them as a table of trig. Derivatives. Okay, the first one, we say that if y is equal to sine inverse of x, then y prime is equal to 1 over the square root of 1 minus x squared. So we can use that to work out what the derivative of our sine inverse of f of x is. So if y is equal to sine inverse of f of x, then y prime, this is equal to f prime of x, the square root of 1 minus f of x squared. So that is how we work out the derivative when what we have over here is not x, but it's some function. So maybe you have sine inverse of e to the power of x, sine inverse of cos x, sine inverse of the square root of x squared plus 1. On the numerator, instead of 1, you have the derivative of that function. And then in the denominator, instead of square root of 1 minus x, you have square root of 1 minus that function squared. Then the second one, we know this one, y is equal to cos inverse of x. We said that our derivative was 1 is negative 1 minus x squared. So you can see here as well, our functions that start with a c, their derivatives are negative, just like with the derivatives of the trig functions. Derivative of cos is negative, derivative of cosec is negative, derivative of cot is negative. The same thing is true here. Cos inverse is negative, cosec inverse is negative, and cot inverse, their derivatives are all negative. Okay, so here now we know what the derivative is when what we're differentiating is cos inverse of x. So what if we're differentiating cos inverse of f of x? We apply pretty much the same thing we did over here. So when y is equal to cos inverse of a function of x, then y prime, this is negative, the derivative of that function in the numerator, and then in the denominator we have 1 minus that function just copy that one. The only difference is this one is negative. That's it. Then the same thing is true for tan inverse. We have y is equal to tan inverse of x. we say that y prime is equal to 1 over 1 plus x squared. So if y is equal to tan inverse of f of x, then y prime is f prime of x 1 plus f of x squared. Then number 4 is y is equal to sec inverse of x. So here you can work out the derivative like I did with the first 3. You will see that y prime is equal to 1 over x, the square root of x squared minus 1. So it is similar to the derivative of cos, except that this one is positive. Okay, and then the x and the x squared, sorry, the 1 and the x squared are switched. With the other one, it was 1 minus x squared. Here it's x squared minus 1, and then there's an x outside. So it will be a good exercise. See if you are able to work this out in the same way I did with the other 3. And then if y is equal to sec inverse of f of x, then y prime is equal to 1 over, sorry, not 1, f prime of x. Then we have f of x here, square root of f of x squared minus 1. So your f of x just replaces your x, and then the numerator is replaced by f prime. And number 5, if y is cosec inverse of x, or arc cosec of x, then the derivative of this one is negative 1 over x square root of x squared minus 1. So again, you can see this is just the negative of that one. Just like the sine and cosec, they are negatives of each other. The derivatives look the same except for the sign. So if your y is equal to cosec inverse of f of x, then y prime is negative f prime of x over f of x multiplied by the square root of f of x squared minus 1. And remember, the functions that start with the c are the ones whose derivatives are negative. Then the last one is cot inverse. So if y is equal to...
Miss, quickly go back. Okay.
So if y is cot inverse of x, then y prime, this is negative 1 over x squared plus 1, or 1 plus x squared. Okay, and this one you can see is almost the same as the one for tan inverse. The only difference is this one is negative. So tan inverse is positive, cot inverse is negative, but the derivatives look the same. Okay, then if we have y is equal to cot inverse of f of x, then y prime, this is equal to f prime of x in the numerator, then 1 plus f of x squared in the denominator. So just like with our standard, our table of standard derivatives, this, we use this when we're working out the derivatives of arc-trig functions. Okay, so now we look at some examples. The first one, we have y is equal to sine inverse of 3x. So here, if y is equal to sine inverse of 3x, so you can see here my f of x is equal to 3x. So something you just take note, even in the back of your mind, your f of x is equal to 3x, and then your f prime of x is equal to 3. So while you're still getting the hang of it, go refer to the table, and then you'll just substitute your derivatives into the formula, depending on which arc-trig you are differentiating. So here, my y prime, if I were to just write down the formula, would be f prime of x over the square root of 1 minus f of x squared. That will be the formula. So I have my f prime here. I have my f of x, just substituting. This is f prime of x, that's 3. Then the square root of 1 minus f of x squared, that is 3x squared. And then you write it out in its simplest form. So you have 3 over the square root of 1 minus 9x squared. That is the derivative of sine inverse of 3x. Number 2, we have y is equal to x squared sine inverse of x. So here we have to use the product rule as well as the arc-trig derivatives that we just learned now. So y prime, using the product rule, the first one as it is, then we multiply by the derivative of sine inverse of x. The derivative of sine inverse of x is 1 over the square root of 1 minus x squared. So here it's an x, so I don't, well, this is the derivative of x, I guess. Well, yeah, definitely it is. So my f of x, then my f prime of x, and then f of x squared. And then the second part is the derivative of the first function. Then you multiply it by the second one as it is. Then write it out in its simplest form. This is x squared over the square root of 1 minus x squared plus 2x sine inverse of x. So remember, sine inverse of x is not the same as 1 over sine x. 1 over sine x is cosec x, and sine inverse of x is not cosec x. So you don't rewrite this as a fraction. That is how you should leave it. And number 3, we look at y is equal to sine inverse of tan of x. So here we have an f of x. So just take note that this, what I'm doing here with the f of x, you can always do it in your mind. But I always tell students, when you're starting out, show as much of your working as possible. That way you'll understand it better. So you have your f of x is tan x. This means that your f prime of x is sec squared of x. Then you remember the formula for the derivative of sine inverse of f of x. So we say that y prime, this was f prime of x over the square root of 1 minus f of x squared. Then just substituting, my f prime of x is sec squared of x. And then in the denominator, I have 1 minus tan squared of x. Sometimes you may get identities in the denominator, but here tan squared of x is not, 1 minus tan squared is not an identity, so we can just leave it like that. Okay, so that is the derivative of sine inverse of tan x. So let's look at some of the questions in exercise 1.2.1. What do we have there? Okay, it's quite a number, so that's enough for you to practice. So exercise 1.2.1. Let's start with number 1. We have y is equal to sine inverse of 3x, which we did already, and cos inverse of x over 2. So here we will have an f of x and a g of x, and remember to incorporate their derivatives. So y prime over here, because this is a sum, I just differentiate the first one, differentiate the second one, and then add the two derivatives together. Simplify as far as possible. So we say the derivative of sine inverse of x. In the numerator, we should have the derivative of our f of x, which is 3. And then in the denominator, we have 1 minus f of x squared, which is 3x squared. So that is the derivative, and we did this one before. And the second one, first in the numerator, we have the derivative of x over 2, which is a half, and then it should be negative. And then in the denominator, we have 1 minus our function x over 2 squared. So that's x over 2 squared. Then just simplifying as far as possible. This is 3 over the square root of 1 minus 9x squared minus 1 over 2 square root of 1 minus x squared over 4. Okay, so there's no need to combine these as a single fraction. That is good enough. Even though you can write this better so that the 4 goes out. What did I get my final answer? Said this is 3 over 1 minus 9x squared minus 1 over 4. Why is it 1 over 4? Should be just 1 there. Okay, so I think you can also simplify it like that. Maybe it looks better than what we have over there. So that from here to there, you just need to play around with it, do a little bit of algebra, which I hope you don't have any problems with. Then number 3, we have y is equal to, let me just correct that. So number 3, we have y is equal to sec inverse of x squared minus cosec inverse of the square root of x. So we do this in the same way. Our y prime, in the numerator, you have the derivative of x squared, which is 2x. And then in the denominator, you have your f of x, and then the square root of your f of x squared. So that's x squared squared, which is x to the power of 4, and then you subtract 1. Then we subtract the derivative of cosec is negative, so negative times this negative, that will become positive. And in the numerator, I have the derivative of square root of x, which is 1 over 2 square root of x. And then in the denominator, you multiply the function, and then the square root of the function squared, that's square root of x squared, is just x minus 1. Okay, then you try and write it in its simplest form. So we have y prime. This is 2 over x square root of x to the power of 4 minus 1. And then over here we have 1 over 2x square root of x minus 1. Okay, number 5. We have y is equal to sine of sine inverse of x plus sine inverse of cos x. Okay, so even before you differentiate, sometimes there will be expressions that you can simplify. So if it's possible to simplify it, go ahead and do that. So for example, this first one, you have sine of sine inverse. Those, like we said, are inverse functions, so they cancel each other out. So what I'm actually differentiating is x plus sine inverse of cos of x. Now we differentiate y prime. This is 1 plus the derivative of cos x is minus sine, and then square root of 1 minus the function squared. Okay, and here 1 minus cos squared, we know, is sine squared, and the square root of sine squared is sine. Okay, so we have y prime. This is equal to 1 minus sine x Okay, interestingly enough, here I'm getting 0 as my answer, but I think even because this is sine x over the square root of that, which is 0. Let me see, I don't know what answer they gave in the book. Okay, in the book they didn't even simplify it, they just differentiated it the way it is, but simplifying it is also fine. Okay, so I'll leave it like that. Well, it is equal to 0. Then number 7. Y is equal to tan inverse of cot inverse of x plus tan of cot inverse of x. Okay, so here again, work out the derivative in pretty much the same way. So we have y prime. We start with the first function. We have tan inverse of cot inverse. So we start by differentiating the tan inverse. Excuse me. The derivative of tan inverse is the derivative of the function on top, and that is negative 1/1 plus x squared. And then we're still differentiating tan inverse. Then it's 1 plus our function, which is cot inverse of x squared. That was for tan inverse of cot inverse of x. Then differentiate tan of cot inverse of x. The derivative of tan is sec squared. So this is sec squared of cot inverse of x. And then you multiply that by the derivative of cot inverse of x, which is negative 1/1 plus x squared. Then you can write your final answer in the simplest way that you can. So what we have, y prime, this is negative 1/1 plus x squared, 1 plus cot inverse of x squared minus sec squared of cot inverse of x over 1 plus x squared. Okay, there isn't really anything that can cancel, so leaving it like that is fine. Okay, I think even trying to combine the fractions will be quite tedious, so we can leave it like that. Then number 9. If y is equal to sine inverse of x e to the power of x. So our y prime, the derivative of the function in the numerator, and to differentiate the numerator, the function, we use the product rule. So this is e to the power of x plus x e to the power of x, and then square root of 1 minus x squared e to the power of 2x. Number 11. If y is the square root of x times cot inverse of x over 3. So here again we use the product rule. So y is equal to the square root of x. We multiply by the derivative of cot inverse, which is negative the derivative of our function on top. And then in the bottom we have 1 plus x over 3 squared. And then or the derivative of square root of x, 1 over 2 square root of x, and then we multiply by the second one as it is. Okay, then this leaves us with, sorry, this is y prime. Y prime, this is negative square root of x over 3 plus x squared over 3 plus cot inverse of x over 3 over 2 square root of x. Okay, yeah, that looks right. Then number 13. Y is equal to ln of sine inverse of x plus the square root of sine inverse of 2x. Okay, so y prime, the derivative of ln is 1 over sine inverse of x. Then we multiply by the derivative of sine inverse of x, which is 1 over the square root of 1 minus x squared. Then the square root of sine inverse of x, this is a half. The sine inverse of 2x to the power of minus a half. Then we multiply by the derivative of sine inverse of 2x, which is 2 over the square root of 1 minus 4x squared. Then simplify it as far as possible. Y prime 1 over sine inverse of x square root of 1 minus x squared plus 1 over the square root of sine inverse of 2x times 1 minus 4x squared, like that. Okay, so I think that is the final answer. Yeah. Okay, so we'll stop here for today, and then on Monday there aren't that many questions left in this section, but you can see it's all about applying the derivatives that are in the table. Keep in mind what the standard derivative is, and then apply it to whatever function it is that you have. Okay.